All right, let's dive into one of the biggest, most fundamental rules of the entire universe, the cosmic speed limit. But we're not just going to talk about what the rule is, we're going to ask why. Why does it even exist? And we're going to do it through the lens of a pretty radical new theory.
You know the rule. It's probably one of the most famous ideas in all of physics. Nothing, absolutely nothing, can travel faster than light. It doesn't matter how fast you're going, light will always fly past you at the exact same speed. But why? Why is that the absolute, unbreakable law of our cosmos?
So, Einstein's theory of relativity, right? It's brilliant. It perfectly describes what happens. It tells us that as you get closer to light speed, time itself slows down for you, your length shrinks, all to make sure that one constant, the speed of light, is never broken. But here's the thing. It's a principle. It's not an explanation. It gives us the rule book, but it doesn't tell us why the rules are written that way in the first place. And this is where things get really, really weird. Because on one hand, you have this super strict speed limit for the universe. But then, on the other hand, you have the completely bizarre world of quantum mechanics. And in that world, a particle isn't in one place. It's a wave of probability, which means theoretically it could pop up anywhere in the entire universe, instantly. So, how can both of these things be true at the same time? It's a huge contradiction. Well, to try and solve this puzzle, there's a fascinating, speculative idea called R-space theory, and its solution is, well, it's pretty out there. It suggests that our whole reality, space, time, everything we experience, isn't actually fundamental. It's just how we perceive a deeper, more basic reality that's made of nothing but pure rotation. Just things spinning. And this slide really gets to the core of it. Look at the image on the left. That chaotic sea of swirling vortices, the theory calls that the R-aether. And that, supposedly, is the true fundamental reality. And somehow, out of all that chaos, the orderly grid of space-time that we know and live in, the image on the right, just emerges. Now, to even begin to get your head around this, you have to just throw out your most basic instincts about the world. In this fundamental R-space, there's no up or down, no before and after. The only two things that actually exist are rotation, a spin, and something called phase, which is really just where a particle is in its spin cycle. That's it. So how in the world do you build a universe from just spins? Let's start with a single particle of light, a photon. According to this theory, a photon is basically a vortex made by combining three separate independent rotations. You've got one for the x-axis, one for the y-axis, and one for the z-axis. Put them all together, and you get a photon.
So what you end up with isn't some tiny little speck flying through space. A photon, in this model, is a complex, self-contained whirlpool, a little piece of reality defined entirely by these three interacting spins.
Okay, this leads to the biggest question of all, right? If the true reality is just a bunch of things spinning in place, where does our world come from? You know, the world of linear distance and movement. How do we get from point A to point B if everything is just a collection of vortices? The theory's answer is a single word, projection. It's actually a pretty intuitive idea. Imagine a point spinning around at a perfect circle. Now imagine its shadow cast on a flat wall. What does the shadow do? It just moves back and forth in a straight line. In the same way, this theory suggests that the spinning reality of our space gets projected into the linear motion that we experience as space. And we actually see this kind of projection all the time. Think about a Mercator map of the world. It takes our round, spherical Earth and projects it onto a flat piece of paper, which is why Greenland looks huge. Or think about one of those mirrored balls. It captures and projects an entire room onto its surface. It's the same idea, a complex, curved reality getting represented on a simple, linear one. Okay, but this projection idea creates a seriously fascinating puzzle. So when the photon's rotation is at the very top or bottom of its cycle, its projected speed is zero, it's standing still. But as its rotation gets to the side of the circle, its projected speed shoots off toward infinity. This means that within a single spin, a photon's projection seems to cover every possible speed at once, from 0 to infinite. And that is the absolute key. A photon might contain this whole infinite range of speeds in its projection, but here's the thing. We can't observe a photon all by itself. To see it, to measure it, it has to interact with something. It has to hit a piece of matter. And according to this theory, matter is fundamentally different from light. So particles that have mass, the electrons and quarks that make you and me, they're also vortices. but their rotational axes aren't stable. They precess, which is just a fancy way of saying they wobble, kind of like a spinning top that's about to fall over. And the most important part is that this wobble is always at a constant 45-degree angle. So, how does this wobbly matter see a photon? Well, the theory proposes one incredibly simple rule. For any interaction to happen, for a measurement to be made, the spin axis of the photon and the spin axis of the matter particle have to line up perfectly. And here it is. This is the big reveal. Remember, the photon's projection contains every single speed, from 0 all the way to infinity. But the matter particle that's trying to observe it has that constant, unchangeable 45-degree wobble. Because of that wobble, there is only one single point in that entire infinite range of speeds where their two spin axes can perfectly align. Just one. And that single, unique point of interaction, that is what we measure as the speed of light, see? So let's just run through that one more time. Matter has a constant 45-degree wobble. To see a photon, their spin axes have to align. That alignment is only possible at one very specific point in the photon's projection, and that point is the speed of light. The cosmic speed limit isn't about how fast a photon is really moving. It's the one constant speed at which our wobbly matter is able to see it. Now, what's really cool is that this idea doesn't throw out Einstein's work at all. It actually complements it. The circular math of R-space and the curved lines of spacetime from special relativity, they're mathematically linked. It's like they're two different languages, using completely different geometric shapes to describe the exact same underlying reality. So in the end, R-space theory gives us a potential mechanical reason why one of the universe's deepest rules exists. And whether it's ultimately right or wrong, it leaves us with a truly mind-bending thought. If something as fundamental as the speed of light is just a projection, a kind of distortion of a deeper reality, what else in our lives, what else that we see every day is just a shadow of a much simpler and much stranger truth hiding just out of sight?